For half a century, human space exploration has had a strict ceiling. Since Apollo, every crewed mission has stayed within a few hundred miles of our planet, tucked safely inside the protective bubble of low Earth orbit. Orbiting Earth is difficult, but venturing beyond that protective magnetic field introduces an entirely different engineering reality. True deep space is a hostile environment, defined by violent radiation, micrometeoroids, and a profound, deadly isolation. NASA's current mandate requires navigating that hostility. The plan is to return to the lunar surface, to establish a permanent base, and use that infrastructure to eventually launch human crews to Mars. You cannot build an interplanetary outpost without first proving your transport vehicle can survive the extreme transition from Earth's gravity out into the deep space vacuum. That is the explicit purpose of Artemis II. This mission is a deliberate, extreme stress test designed to push a brand new spaceflight architecture to its absolute physical limits. 4 astronauts, Reed Wiseman, Victor Glover, Christina Koch, and Jeremy Hansen, will fly inside the newly built Orion spacecraft, named Integrity. Their flight plan dictates a grueling 10-day journey, covering more than 685,000 miles on a path around the Moon and back. The crew will spend those 10 days running a meticulous engineering gauntlet. They will intentionally tax life support, execute complex navigation maneuvers, and monitor resilience under thermal extremes. The entire multi-decade plan to colonize the Moon hinges entirely on the data gathered during these 10 days of calculated, intentional stress. Breaking Earth's orbit with a heavy human payload requires generating staggering amounts of thrust. The Space Launch System, or SLS, is a towering heavy-lift rocket built specifically to carry the massive weight of the Orion capsule and its crew. Supporting a rocket of this size requires a massive footprint on the ground. Facilities like the Vehicle Assembly Building at Kennedy Space Center have been updated to support a continuous campaign of heavy launches, rather than a standalone event. During liftoff, the core stage engines and solid rocket boosters ignite to generate millions of pounds of kinetic thrust, vibrating the entire structure as it fights atmospheric friction and gravity. Once in orbit, the rocket's upper stage performs the translunar injection. This is a critical, sustained engine burn that accelerates the spacecraft to speeds fast enough to escape Earth's orbit and commit the crew to the Moon's gravitational pull. Surviving the violent shaking and G-forces of launch is the first physical hurdle. The true test of the vehicle begins the moment the engines cut off and the hardware drifts into the void. By April 6, 2026, 6 days into the flight, the crew of Artemis II surpasses the absolute distance record for human spaceflight, a mark held by the Apollo 13 mission since 1970. This diagram shows the true scale of that distance. The capsule passes the 248,655-mile mark, pushing far beyond the boundary of low Earth orbit. The Integrity continues outward to its maximum apogee, reaching 252,756 miles from Earth, intentionally establishing a new boundary for human travel. Looping back toward the Moon, the spacecraft enters an active testing phase as it skims within 4,067 miles of the cratered lunar surface. Passing behind the Moon's far side creates an intentional 40-minute communication blackout. This period of radio silence forces ground control to test the tracking and signal recovery capabilities of NASA's Deep Space Network. During this extreme isolation, the astronauts track vital physiological data on how their bodies handle deep space, while using digital handheld cameras to capture high-resolution photography of the shadowed lunar terrain. Pushing past Apollo's distance record provides the hard data required to prove the vehicle can sustain a living crew in the deepest, most isolated regions of our local space. The final, high-stakes phase of the stress test occurs when the capsule hits Earth's atmosphere, enduring massive thermal loads and physical turbulence upon re-entry. After splashing down off the coast of San Diego, military and NASA recovery teams retrieve the crew and capsule aboard the USS John P. Murtha. Retrieving the physical sensor data and telemetry logs from the capsule provides the engineers with the evidence needed to validate the entire SLS and Orion architecture. With the transport systems proven safe, NASA can formally authorize Artemis III, a mission to physically land astronauts near the lunar South Pole. Apollo crews went to the Moon to observe and return. Artemis uses those lessons to extract resources, build habitats, and construct a permanent human presence. Artemis II proves the transportation network works. humanity's interplanetary expansion has officially begun, leaving a new, distant record for the next generation of engineers and astronauts to break.